Good afternoon, ladies and gentlemen, and welcome to this clip where we look at if mesh quality affects load distribution. And this will all be done in Pro Consumer module just because meshing is super easy. It is, in fact, predominantly automated. You can adjust the average mesh element size, but the process is largely automated. So my name is Jacobus Oberholster. I'm an AEC and Procon technical consultant for Micrographics. And you can see my email address there, and you're welcome to get hold of me if you have any specific questions. Otherwise, you may pop them in the comment section below, and I'll be sure to get to them as soon as possible. So without further ado, let's jump into this. So here we have a very basic sumo model. We've got a concrete slab on top of 4 concrete columns. And if we go to the discretized model view, and for some reason this is now not wanting to play ball, there we go. So in the discretized model view, we can actually see the quality of the mesh, and we can see that this is quite a coarse mesh. Right. And in general, what I've noticed is that if engineers aren't designing the plane elements themselves, they pay very little attention to the actual mesh quality. And what I'm hoping to do is to show that your mesh quality should always be something that you pay careful attention to, even if you're not particularly focused on designing the plane element itself. Right, so I've already run the analysis, but I'm just going to run it again. Right, and we can go to the results workspace. And what we're interested in, just as a basic starting point, is looking at the axial forces in the concrete columns themselves. Now, this is a symmetrical 5x5 slab, and the whole arrangement is actually symmetrical about both axes. So we should see exactly the same axial force in each one of the columns. So if I go to beams and I check axial force over there, I've only got one load combination. We can see that although the difference is minor, that there is a difference in the actual forces within each of the columns. Right, now, is that as a result of the mesh quality? So let's find out. I'm going to go back to the standard workspace, select my slab, adjust the mesh size to something like 0.5, go to modify mesh all. That looks like a very nice mesh. I'm going to run my analysis again. Right, let's go to results, beams, axial forces, and we can see that all 4 are identical. Now, what you might be saying is, well, that difference is absolutely negligible. But imagine a multi-story building where this, in a sense, this error gets carried over from floor to floor. If you have 10 stories, it is possible that the effect can actually be quite significant. I've looked at something very simple. This is a very simple arrangement, but you can have more complicated arrangements as well that could further exacerbate the problem. And I think that this will be especially relevant with what I just mentioned, and that is multi-story buildings, where actually that effect could be carried down from floor to floor to floor. And that is definitely worthwhile investigating in a more comprehensive video. But for now, this would be the end of this clip where we looked at whether or not your mesh quality actually affects the load distribution from your slab or from your plane elements to the actual supporting elements. And we can see that it definitely does. So I hope that this sparks your interest a little bit, that you'll be spending a little bit more time looking at your mesh quality, even if you're not going to design the plane shells itself or plane elements, that your mesh quality you'd still consider your mesh quality to be important. So thank you so much for tuning into this very short clip that will hopefully open up some future topics, but I hope you enjoyed it. And if you haven't already, please like and subscribe and throw anything in the comment section there if you enjoyed the clip, if you have questions, and I'll get to them as soon as possible. Hope that you have an epic week further, and see you soon.